this example, we're going to look at application of a normal distribution where we will take our original data values and we will convert them to z-scores and then find a corresponding area under the curve that will correspond to a proportion of items that satisfy a characteristic. Then we will be given a percentage that we need to hit, and we're going to find the data values that would ultimately create that percentage. And we're going to do all this using our table in order to find either the z-scores or to find corresponding areas. So here we go. Suppose Dup's Potato Chips Company manufactures an 8.0 ounce bag of potato chips. The distribution of weight in the bags manufactured is approximately normal with a mean of 8 ounces and a standard deviation of 0.21 ounces. A local chain store orders a shipment of 1,500 bags of the Dup's potato chips. So the first question is, how many bags of chips will be less than 7.5 ounces? So we're looking at the percentage of chips that satisfy this given characteristic, and percentage can correspond to the area under the normal curve. So let's go ahead and sketch ourselves a curve with the information that we've been given. So on our normal distribution, it has a mean of 8, so we'll put that in the center of a normal curve, and a standard deviation of 0.21. And I just like to label that in the center just so I have it for reference in case I want to get an idea about the spread. Now on this particular problem, they want us to know how many bags of chips will be less than 7.5 ounces. My mean is 8, so 7.5 is something that's less than 8, so I'm going to put that to the left of 8. So just mark somewhere where you think 7.5 is. And I want to find out how many bags will be less than it. So less than it would be to the left. In order to find out how many bags satisfy that percentage or that proportion, we're going to find the area under this normal curve that is to the left of 7.5. Right? So I want to find this area. In order to do that, we are going to convert our value to a z-score. So for the 7.5, its z-score is 7.5 minus my mean of 8 divided by the standard deviation, which was 0.21. And rounding to 2 decimal places, we get a z-score of negative 2.38. So then we can kind of see what's happening. Sketch a new curve. We'll be on the standard normal distribution now. So the standard normal distribution has a mean of 0 and a standard deviation of 1. And the z-score that I want to mark on here is negative 2.38, which is going to be somewhere over here to the left of 0. And I want to find the area under this curve to the left of the 2.38. So it's the exact same picture I just sketched previously. We've just standardized the variable to be working on the standard normal curve. So we want to find this area. So notice that we are wanting the area to the left, which is helpful because it's exactly what Table A gives us. Table A will give us area to the left of a particular z-score. And in this case, the z-score I'm looking at is negative 2.38. So to the table. We find negative 2.38. So here is negative 2.3 over here on the left. And then I'm going to slide across till I get to 8 column. So where that row and that column meet, it's giving me a value of 0.0087. Right, so this area is 0.0087 using my table. So how many bags of chips will be less than 7.5 ounces? Well, what we've gotten so far is that we know 0.87% of the bags will be less than 7.5 ounces. Right, so then coming back to the question that's being asked of us, so how many is that? And then that's assuming that the shipment is 1,500 bags. So out of the 1,500 bags, there would be, and let's figure out what 0.87% of 1,500 is. So the 0.87% as a decimal was 0.0087. We'll multiply that by our 1,500. And that's giving me approximately, actually it's giving me exactly 13.05, so about 13 bags. Out of the order would be less than the 7.5 ounces. So remember that the area under the curve is giving us a probability, or you can interpret it as giving us the percentage or the proportion of items that fit a certain characteristic. And in this case, we were analyzing in terms of the percentage of items that's met a characteristic. And the characteristic we're tracking here is less than 7.5 ounces. So let's take a look at this next one. It says if the chips, the bag of chips must be within the middle 80% of the mean weight before the store will accept the order, what weights must the bags be between? Now again, a sketch is very helpful to kind of see what is going on here. So we'll sketch a normal curve. It has a mean of 8 ounces and a standard deviation of the 0.21 ounces. All right, I want the chips to be between the middle 80% of all of the mean weights. So middle 80% would be, if I were to put down some markers, so maybe something here and here, to the left and to the right of 8, such that the area in between them, this area, I want that area to be 80%, or 0.80. We want to know who this value is to the left and who this value is to the right. Okay. These weights that the bags must be between, such that it captures this middle 80% around my mean. So let's go ahead and find those two values. So, and just for the sake of later calculations, I'll label this value to the left x sub 1 and this value to the right x sub 2. All right, so if I know that the area in the center region is 80%, and remember that the total area under the entire curve is 100%, that leaves 20% of the area in those tail regions. Now the tail regions are symmetric, so that means each tail has half of the 20, or 10% area. So what that means is over here in this tail region, this area is 10%, or 0.10, and out here in the left tail region, that also has an area of 0.10. So we can use our table to find the corresponding z-scores that would compare with those areas. So remember, when you're given areas and you're trying to find z-scores, the area information is in the center of the table. So I'm going to go over here and I'm going to find this left one first. So we're going to find what this z-score is, such that the area to the left of it is 0.10. All right, so to the table. I expect that z-score to be negative because it's over there on the left region. So 0.10, looking through my table trying to find the value that's closest to it, and it looks like it's right here. I'm getting 0.1003, so that's really close to 0.10. So what is that z-score? It's negative 1.28. All right, So maybe let's write ourselves a little note. We got a z-score of negative 1.28 from the table where the area that we used, and I just like to remind myself what I was looking at, the area that we found in the table was, let's go back here, 1003. So 0.1003 was the area I found in the table. Alright, so that's going to be the z-score on the left. Let's find the z-score on the right. Now for this right z-score, when I go to find it, I need to remember that with respect to that value, the area to the left of it is 1 minus 0.10. Remember, the 0.10 is the area to the right of it, so if I want to get to the area to the left of it, it's 1 minus that value, or 0.90, or 90%. I need to figure that out because my table only gives me area to the left. So I needed to figure out what the area to the left of that z-score was. If you had wanted to take your 80% plus another 10%, you also get 90. All right, so it's a different way to think about it, but it also works. All right, so the area I'm looking for is 0.90. So to the table. Looking in the heart of the table for 0.90, as close as I can get to it. So 0.9032, 0.9015, 0.8997. That's really, really close to 0.90. What is that guy's z-score? It would be 1.28. Cool. We just got the z-score of 1.28. And what we had found was the area in the table that we looked at was 0.8997. Now again, because of the symmetry of this curve and because we have the same area that we want to the left as we want to the right, you actually didn't really even need to use the table to find this z-score over here on the right. It's going to be the opposite sign of the value found over here on the left. And again, we can only do that because of the symmetry that I'm having 10% in both of those tails. If I had a different area in one tail versus the other tail, you would just have to manually find what those z-scores are. Alright, so now I know for the z-scores for my data markers, but this problem doesn't want me to report back the z-scores. It wants me to report back the actual data value. Alright, so let's go ahead and convert these z-scores to data values. Alright, so for my x1, remember that the computation is the z-score is your data value minus your mean divided by your standard deviation. So for this value over here to the left, the z-score is negative 1.28. I don't know the data value, so that's unknown. But I do know that my mean is 8, so I'll substitute that in, and the standard deviation is 0.21. So I can then solve that equation for that unknown value in my numerator. So to solve for it, we'll multiply both sides by 0.21 to get rid of that fraction. So then I'm going to get negative 0.2688 is equal to x minus 8. To undo subtracting 8, we'll add 8 to both sides, and we end up with 7.7312 is equal to that data value that would be on the left. We'll repeat the same game with the value on the right. So 1.28 is equal to the data value that I want, which I'll call that x sub 2, minus 8 divided by 0.21. Again, we'll multiply both sides by 0.21, and we'll get positive 0.2688 is equal to the data value x2 minus 8. To undo subtracting 8, we'll add 8 to both sides, and we end up with 8.2688 is that data value that would be to the right. Right, so notice that I can't use symmetry on these ones. So you can't be like, for instance, when you get the 7.7312 as that value to the left, you can't like take its opposite sign to get the value to the right. Okay, so you have to, that only works when you're doing the z-scores. So we'll have to actually just do the computation to figure out that left data value and that right data value. So what we've just found here is that if I want to look at the chips that are within the middle 80% of that mean weight, the weights of the bags must be between 7.7312 ounces and 8.2688 ounces. And then again, as a reminder, depending on how you're getting like some of your areas and z-scores, whether or not you're using the table like we did or different technology sources, you might get values that are just slightly off because of rounding and how many decimal places are being saved and all that stuff. All right, so for the last part of this question, if the store will only accept the order if the chips are within the middle 80% of the mean weight, how many bags of chips should Duff's manufacture to ensure the store will accept the order? Another way to maybe word this question is, how many bags should they make such that when they keep 80% of those bags, they have at least 1,500 bags? So they're going to need to obviously make more than 1,500, right? So if they only make 1,500 bags and they're only going to be able to keep 80% of them, then they're going to toss out some bags, 20% of the bags, and now they don't have enough. So the value that we're looking at is definitely going to be more than 1,500 bags, because there's going to be some that are being discarded, but the question is how many more. So we can use a percent equation to solve that. So the percent equation is the part is equal to the percent times the whole. But when we use the percent equation, the percent has to be expressed in its decimal form. So we're looking to figure out what is the whole, or how many bags total must they make, such that when they keep 80% of those bags, the part that they have remaining in order to give to the people who are ordering the bags, the part they have remaining is 1,500 bags. So we need to figure out then how many total they should make. So we'll divide both sides by 0.80, and we find that the whole, or how many bags they should make, is 1,875 bags. So that is the minimum number of bags that they should manufacture, such that if they expect to keep 80% of what they manufacture, then they will have 1,500